With any luck, you've just successfully completed the target lab, and so you took one of our projectile launchers and you launched a projectile successfully into a cup. Let's talk about that process, and in particular, I want to talk about something called modeling to help discuss what went on in this. So if we were to draw a picture of what happened, it's a pretty simple idea that you have a table some height above the floor, and you have this projectile launcher that is going to shoot a ball, and you had to get it in a cup, just like that. So seemingly all you have to do is you have to determine the height that it started from. You have to determine the initial velocity vector, and that includes the angle. And then what you do is you break down that angle into its components so that you have a horizontal and a vertical initial velocity, and you solve one of the angled projectile motion problems just like we saw in the other video. It's a complicated process, to be sure, but at the end of it you should end up with the range, that is how far in this direction the projectile would travel. And all you then have to do is put your cup in front of that and hit it. So let's talk about some things where this might have gone not as you expected. So first, this is what we would call an ideal model. So this is in your head using nothing but the ideas of physics. This is exactly how the problem should work. There shouldn't be any question of this. If you have the initial velocity and the height, you should set it up, and every time it should hit in that cup. You probably noticed that this was not what happened. And so what happens is that life intervenes. There are different parts that we have to call into question. So this is a general model that we would use to give us some idea. And it doesn't give perfect results, but it gives pretty darn good results. You will be in the ballpark from here. So let's talk about ways the model breaks. First, with the initial velocity. Because if you're using this model, you're assuming that you know the initial velocity perfectly and that it's the same every time. Now you will have noticed that the machine you were using to launch the projectile is not a perfect machine. The speed is not going to be exactly the same every time. It's going to be close, but it's not going to be exactly the same. If you wanted to add a level of complexity to this, you could take many trials where you're determining the initial speed of the projectile, and from there what you could do is you could determine the range of possible initial speeds from a given setting. So you could find what percentage your actual speed may vary above or below what you think it is. So this isn't perfect. All we can do is take the best measurement we can and roll with it. Also, this is a minor thing that is an easy fix, but with the height, make sure you're getting the actual height that the projectile starts from, not just the height of the table. That's been something that in the past students have messed up. Also, note this, that we are calculating the range to right there, the inside of the cup. But you'll notice, even though I drew it coming in from the top, that most of the time the ball will skin in from the side. So it's not so much that we need to find exactly where the target hits on the ground, but rather we need to find the spot where the ball will slide in at the height of the cup at the opening of the cup, a slightly more complex problem. So we can use the spot on the ground that we think it's going to hit, and that'll get us results that are pretty close, but you probably had to slide your cup a little bit one way or the other to account for the fact that this ball has to go in from the top. Now, all in all, I hope what you saw here is that our model, using just these perfect numbers that we think work every time, was close enough to be very useful to us, but that there are a great number of real-life situations that you have to apply to it. In physics, what we do is we look for the most general situation, the one that tells us the most about whatever situation we're at. And then when you start dealing with these more practical issues of this, you start getting into the realm of engineering. So again, physics is the big ideas of how this works, and the engineering part of this is where you look at the specifics of how each part is interacting. Very interesting stuff, and something that maybe you will want to pursue in the future.